Tim Rablitz from Tulip Services, Solution Lead. And in this video, I'm just going to do a quick walkthrough on how to set up a simple sense and respond type capability using some third-party Phidgets and Tulip Automations. So here's the use case. You have some equipment that, say, does not have a PLC, so in practice you generally cannot read data from it or write data to it. And in this case, I'm just using a kitchen oven, and I want to bake bread until the internal temperature of that bread hits 190 Fahrenheit. Then I want to know as soon as it hits 190 and pull that bread from the oven to prevent the bread from over baking. Some of you may be familiar with our operational flow diagrams, or OFD, so let's take a look at the solution from an OFD perspective. So we have no third-party systems involved here like an ERP, and as far as devices go, we're just using a Tulip Edge MC and a few third-party products by the company Phidgets, including the Phidgets Vent Hub, the Phidgets thermocouple widget, and a physical thermocouple as well. So machines, there's just one machine involved here, and there's just one table that is part of the solution. So it's just an equipment table wherein we are configuring what a set temperature is and whether or not to send an alert. Apps, so there's just one simple app that an operator uses that is used for just setting that alert temperature and just triggering whether or not to send the temperature out, as well as seeing the real-time value of the temperature from that thermocouple through the mapped machine. Also, there is an automation involved here, and the whole purpose of the automation is just to look at that value that's coming from the thermocouple, compare that with the temperature that we have set, and if the thermocouple is greater than or equal to that set temperature, then a message will get sent out. A SMS text message will get sent out. So from an OFD perspective, that's really all there is to it as far as how this solution is designed. So let's dive into a little bit more detail. So in the top right, we have a few third-party products. We have this K-type thermocouple. We have a Phidgets isolated thermocouple Phidget. And we have, by Phidgets, the Vent Hub, basically the Hub 0001. That Vent Hub is connected via USB to the Tulip Edge MC. And I'm just using a simple Node-RED flow to get that value from that thermocouple into a machine attribute tag. Let's just take a quick look at that. Okay, this is just the connect node, the Phidgets Node-RED connect node, and this is the node for the temperature sensor. There's a few attribute values here that are not relevant to us based on that we're using a K-type thermocouple, so this RTD wire setup, RTD type, that's not relevant to us. But so thermocouple type is K, great. And I'm just feeding this value every 5 seconds. I could probably get away with longer than 5 seconds, but I don't really care about seeing anything more recent than 5 seconds ago. And this change node is just a change it from Celsius as received back from the Phidgets hub to Fahrenheit. And then I'm just feeding that into a Tulip machine attribute node. Great. So that's automation. Let's take a look at the automation and see what that does. All right, so the first thing I'm doing is seeing, hey, the kitchen thermocouple temperature attribute value changed. Let's get the table record that we just talked about and do some evaluation. So first of all, is the alert at temperature, it's not blank, right? And the alert at temperature is less than or equal to the value that I'm getting from that machine, and my alert me boolean is true. If that's all correct, then I send a simple message, just a simple text message that says oven at alert temperature, and I just do a simple quick update to the table record to trip that boolean, that alert me boolean to no. That way I do not receive a million text messages. Recall, I just have a really simple mobile app here to set the temperature and set whether or not I want to be alerted. The mobile app also shows that real-time value of what is the current temperature that I'm getting from my machine. That's pretty much it. So again, have some Phidgets feeding into a Node-RED flow, feeding that into a machine, and with automations, I can see, is this value greater than or equal to a temperature that I've set in a table record? And if so, go take some action, like send a text message, and I receive that message immediately, and I pull that bread from the oven and prevent it from over baking. Well, I can't talk about all this bread baking and just not show an actual attempt. So here we go. I waited about 10 minutes until I put the thermocouple in the bread, just to make sure that the bread was firm enough to accept that thermocouple nicely. And I'm lucky in that the thermocouple braided wiring here is small enough, in diameter that it did not, prevent the oven from being nice, say, thermally sealed. Here we go. We see we're at 187 Fahrenheit, so really, really close. And I had an alert at 190, and boom, just a moment later, I get my text message, oven at alert temperature. So I promptly remove the bread from the oven. There's our beautiful finished product. Nice golden brown, decent crust as we expect and want. So anyway, a fun little use case, but I hope you found this valuable and find some way to incorporate this proof of concept in your own facility with a real production use case, which might be baking bread. Thanks all for tuning in.